Factoring is one of the most important skills that you can have in algebra, and sometimes you're asked to just factor and other times you're asked to solve by factoring. So we're going to look at both scenarios in this video. So if you're just asked to factor or find the factors, you want to make sure that your quadratic is in standard form, which is ax squared plus bx plus c. So x squared is at the beginning, x is in the middle, and the constant c is at the end. You want to make sure that you always check for a GCF, or a greatest common factor. If there's one, you will factor it out. Remember that it will not disappear. If there's not a GCF, that's okay, then you'll just skip to step 3. So step 3, there's a lot of different ways to factor. We're going to use the star method. So you'll create a star like the one at the right, and up top you will multiply a times c and put that value there, and in the bottom you'll put the value of b there. And then on the bottom halves of the star, so right here, you're going to put the value of a, and that will be, if you had a GCF, it'll be your new a value. And your task is to find two factors, and we're just going to call those P and Q. We want them to add to give you B, but multiply to give you AC. So the two numbers, P times Q has to equal AC up top, and then P plus Q has to equal the B in the bottom. You're really going to need to pay attention to the signs because the signs do make all the difference. Once you divide P and Q by A, you're going to see if those fractions simplify. They may or they may not. If they don't, that's okay, but if they do, do make sure you simplify them. Those fractions will become your factors, and we call that bottoms up. So if you have a GCF, you're going to write that in the first position right here. And then from the bottom, you'll do A times X plus P, again using your simplified values if it's simplified. And then for the other factor, ax plus q. You can always check your factors by foiling. If you need to solve, you will have an equation and you will set your factors equal to 0 and solve each of those equations. So we will do some of those later in the video. Your solutions are also known as your roots, your zeros, or your x-intercepts. In Algebra 2, you often use the word roots or zeros. In Algebra 1, we tend to say solutions or x-intercepts. And you'll be applying this not only with quadratics, which is x squared, but you'll learn how this plays a role in cubic functions, quartic functions, quintic functions, all types of polynomials. Some important things, not every quadratic is factorable. Obviously, since we're learning how to factor, the problem's going to give you will be factorable. But when you get to Algebra 2, you're going to learn what to do if it's not factorable. It is very helpful if your A value is positive. So if it's not, I would suggest dividing a negative out. When you write your factors, when you do bottoms up, you should never have a GCF. If you do, that means you didn't simplify. And we have two special cases, and the first one is when it looks like ax squared plus bx. And if that's the case, that means that your constant is 0, and there's only going to be a GCF. You actually won't do the star method in that because when you take out your GCF, you'll no longer have a quadratic factor, and so you can't do the star unless you still have a quadratic factor. If it's ax squared plus c, that means your b is 0, and you can still do, you can still factor, or at least try. Again, not everything's factorable. So for our first example, we are going to look strictly at a factoring problem. We're going to follow our steps. So the first step is to make sure that we're in standard form, which we are. Your second step is to look for a greatest common factor. There is no number or term that divides evenly into x squared, 5x, and 6 except for 1, and dividing by 1 does nothing. So we are ready to identify A, B, and C. A is the number in front of x squared, which would be 1. B is what's in front of x, which is 5. and c is the constant, so 6. We're going to do our star. Remember, in the top is a times c, so 1 times 6 is 6. In the bottom is b, so that's just 5. And then in these bottoms, that's the a value, which are 1. So now we need to think about our factors of 6. We have 2 pairs of factors for 6. We have 1 and 6, or we have 2 and 3. And we need to think about which one of those pairs can be manipulated to give us 5. And technically they both can, but only one pair with the correct signs will work. And so since my 6 is positive and my 5 is positive, that means my 2 numbers are going to be positive. So if I pick positive 2 and positive 3, multiplied, that gives me positive 6, and added, that gives me 5. So those are the correct pair. Can't use 1 and 6 because if I add those together, that gives me 7 when they're both positive. So now we're looking at these fractions and we're looking to see, can we simplify 2 over 1 and 3 over 1? No, so now we're ready to do bottoms up. If it is helpful, you might want to add an x to your denominator. So you're going to start in the bottom and you're going to write 1x bottoms up, so go to the top, and that's a positive 2, so plus 2. And then on the other factor, the bottom is 1x, and up is plus 3, or a positive 3. Now we technically don't need those 1s in front of those x's, so I'm going to get rid of those. So it's x plus 2 times x plus 3. And it would be completely okay if you wrote x plus 3 times x plus 2. Because it's multiplication, the order in which you write the factors does not matter. So that is called your factored form. Each of those binomials, the x plus 2 and the x plus 3, are called factors. And if you ever want to check it, it's pretty easy to check. You can just FOIL. So if you did x times x, that would be x squared. I'm just going to kind of check it off to the side. If you did x times 3, that's 3x. 2 times x is positive 2x. And 2 times 3 is positive 6. And if you combine the 3x and the 2x, that does give you a 5x. So you're looking just at different forms. So what I gave you was standard form. What we came up with was factored form. For our next example, first step, make sure it's in standard form. Yes, it is. Step 2, check for a GCF. This time we do have a GCF. 2 divides into all of those terms. So I'm going to start by dividing all of them by 2. That 2 is not going to disappear. It is going to be in front of your new factor. So 2x squared divided by 2 is just 1x squared, or just x squared. Negative 16x divided by 2 is negative 8x, and 30 divided by 2 is 15. So when we go to identify a, b, and c, we're going to use the new a, b, and c, not the original. So our new a value is 1, our new b value is negative 8, and our new c value is 15. So as I do my star, a times c goes up top, so 1 times 15 is 15. B goes in the bottom, so that's negative 8. And then my a value, 1 and 1 on those bottoms as well. So now we're going to think about factors of 15. We have 1 and 15, 3 and 5. Those are the only combinations that exist. You cannot mix and match them. You're either going to use 1 and 15 or you're going to use 3 and 8. And we can manipulate 3 and 5 to give us a negative 8 if we make them both negative, because negative 3 plus negative 5 is negative 8. Sometimes there's more than one way to get the correct sum, but there is only one way to get the correct product and correct sum. So I encourage you to double check once you think you have the correct numbers. Double check and make sure that product is correct. So negative 3 times negative 5 is positive 15. And negative 3 plus negative 5 is negative 8. So we know that we have the correct factors. So now we're going to look at those two fractions and we're going to see if they simplify. Negative 3 over 1 doesn't simplify. Negative 5 over 1 does not simplify. So now we're ready to write our factors. When you write your factors, you're going to start with any GCF, which was 2. And then we're going to do bottoms up. Remember that you might want to put an x after your number in your denominator. So the one on the left becomes 1x, or just x minus 3. And the one on the right becomes 1x, or just x minus 5. Anytime you want to check this, you would start by foiling, and then after you foil, you would want to distribute that GCF. So I'm just going to do that off to the side. I usually do it on my head. I don't actually show it, but for purposes of the video, I'm going to show you. So I would do x times x, which is x squared, x times negative 5, which is negative 5x, negative 3 times x is negative 3x, negative 3 times negative 5 is positive 15. Remember that foiling, it really just means distributing. So if you were to combine like terms right there, that's a negative 8x. And if you multiply 2 times x squared, it gives you 2x squared. And if you multiply 2 times negative 8x, that gives you negative 16x. And if you multiply 2 times 15, that gives you 30. So you know you have factored correctly. All right, for our next one, standard form, check. GCF. There is a GCF. This time, I am going to do a negative 2, not just positive 2, because our a value is negative, and it really factors a lot easier if your a value is positive. It can be done when it's negative. It's just a lot easier when it's positive. So when I take negative 8x squared and divide by a negative 2, that gives me positive 4x squared. A positive 8x divided by a negative 2 is negative 4x, and a positive 6 divided by a negative 2 is a negative 3. So my new values of a, 4, b, negative 4, and c, negative 3. Let's do our star. Up top is a times c. So we have 4 times negative 3, which is negative 12. Bottom is b, negative 4, and we are going to divide both of them by a, which is 4. All right, so factors of 12. We have 1 and 12, 2 and 6, 3 and 4. Which pair can we manipulate to give us a negative 4? Well, the only one that can be done with is 2 and 6, but not positive 2 and positive 6, because when multiplied, that would give me positive 12, and when added, that would give me 8. Since I have a negative AC, one of those numbers needs to be negative, not both of them. So to get a negative 4, I'm going to need that 6 to be the negative number, because 2 times negative 6 is negative 12, and 2 plus negative 6 is negative 4. We look at our fractions and we see, can they simplify? Yes, they can. 2 divided by 4, 2 goes into both of them, so that becomes 1/2. And negative 6 over 4 becomes negative 3 over 2, because I'm going to divide both of those by 2. Now we're ready to take those fractions and make them factors by using bottoms up. So remember that before you do bottoms up, the first thing you want to write is that GCF, which was negative 2. I'm going to take the fraction on the left, that 1 over 2. I'm going to attach that x to 2. The bottom is 2x. Up is 1. Bottoms up. The one on the right in the bottom is 2x. Up top, negative 3. So negative 2 times 2x plus 1 times 2x minus 3. Again, that is called factored form, and each thing that you're multiplying is called a factor. So the GCF, greatest common factor, negative 2 is a factor. 2x plus 1 in that first set of parentheses is a factor, and 2x minus 3 is also a factor. The word factor can be used as a noun, so this factored form has 3 factors, and it can also be used as a verb. What we just did was factor. So it's a process, but it's also a thing. All right, so our next one, hopefully as soon as you look at it, you think that looks a little bit different because there's 2 terms and not 3 terms. That doesn't necessarily impact our steps. We still approach it the same way. We make sure it's in standard form. Yes, it is. We look for a GCF. There is one. This is the one that a lot of students make a mistake. So the GCF, a lot of students will say 5. And 5 is a factor, but it is not the greatest common factor because they also both have an x. So our greatest common factor is 5x. So I'm going to take a 5x out of both of them. Make sure that 5x does not disappear. If I divide 5x squared by 5x, I'm going to divide 5 by 5, which is 1, and x squared divided by x is just x. You subtract the exponents. You have 2 up top, you're taking 1 away, so that leaves you with just an x. 50 divided by 5 is 10, negative 10, and then I have an x up top, and I'm dividing by an x in the bottom, so that's going to leave me with no x's. So when I take out the GCF, I just have x minus 10 left as my factor. And what you'll notice is I don't have a quadratic inside that parentheses like I did on my first 3 examples. And so I can't identify A, B, and C because it doesn't exist. When you took that GCF out, it made that factor go from a quadratic to a linear factor. And so this is as far as you can go with this. You can't do the star unless you still have an x squared. And yes, there is a hidden x squared, because if you were to distribute 5x times x, that x squared comes back. But when you take that GCF out, there is no longer a quadratic factor, and so you can't go any further. So the factored form is just 5x times x minus 10. So one of the things I put on one of those earlier slides about like important facts to know or fun facts, whatever it said, is that if your C is 0, which this one is missing a constant, it is a GCF only problem. You will not be able to factor any more besides taking that GCF out. And these are ones that students tend to overthink, but they're really the easiest one-step problems. Number 5 kind of looks like number 4 because it has 2 terms, but this time it's not the constant that's missing. We have a constant. What's missing is that middle term, that bx. So is it in standard form? Yes. Is there a GCF? There is. There is a GCF of 3, so I still need to take that out, but not 3x this time because that 300 doesn't have an x attached to it. So I'm going to pull the 3 out, and that's going to leave me with x squared minus 100. So because I still have that squared right here, that means I still have an a, and I need to keep trying to factor further. Now, when you get to Algebra 2, there will be times where you won't be able to factor this further, but we can keep going. So we are going to keep going. So for this one, our a value is 1 because that's what's in front of the x squared. B, there is no just plain x. That means B is 0, and our C is negative 100. So when we do our star up top, A times C is negative 100, B is 0, and we're going to divide by A, which is 1. So what 2 numbers multiply to give us negative 100 but add to give us 0? And again, for some people, finding these factors is going to be really easy, and for other people, this is going to be where they spend the most time. So if you're not good at factors, just start with 1 and keep going until you list them all out. So 1 and 100, there's no way to make that 0. 2 and 50, right? If I add them, I get 52. If I subtract them, I get 48. No way to make that 0. 3 does not go evenly into 100. 4 and 25. No way to get 0 out of 4 and 25. 5 and 20. No way to get 0. 6 does not go into 100. 7 does not go into 100. 8 does not go into 100. 9 does not go into 100. But 10 does. 10 and 10. And I can definitely take 10 and 10 and make that 0 if I make one of them negative, which I would need to make one of them negative because 10 times negative 10 is negative 100, and 10 plus negative 10 is 0. So now that I have my factor pairs and I divide them by A, I'm going to see if I can simplify those fractions, and I cannot. So now I'm ready to do bottoms up. Remember to always include that original GCF, which was 3. I'm going to throw my x's in the bottom. You don't have to do that step. It just kind of helps me remember that that's where I need to start, is the bottom. So that becomes 1x plus 10, or just x plus 10. And on the right side, we have 1x, or just x minus 10. And that is our factored form. So this has three factors. The GCF is a factor, x plus 10 is a factor, and x minus 10 is a factor. The factors are important because the factors will lead you to the solutions, which we'll be doing after the next example. It'll be the same process, but then there'll be an additional step to find those solutions. All right, so last example of just factoring only and no solving. We have it in standard form, so step 1 is done. Step 2 is GCF. This does have a GCF of 3. So we're going to divide everything by 3. If you find that you're forgetting the GCF, as soon as you divide by 3, maybe make it part of your factored form. Like, go ahead and write it down. That is a really common mistake for students, to forget that GCF. All right, so when we divide everything by 3, 27 divided by 3 would be 9x squared. 90 divided by 3, negative 30x, and then plus 25. So our new a value is 9, our new b value is negative 30, and our new c value is 25. Let's do the star. All right, up top is a times c, so 9 times 25 is 225. Bottom is b, and then my other two bottoms are a, which is 9. Again, there may be some of you who instantly, oops, sorry, I forgot the negative on the b, who instantly recognize that pair of factors, and then there's going to be some of you who are like, I have no clue. And so if you are that person who has no clue, go through your factors one by one. 225 divided by 1 is obviously 225. 2 does not go into 225. Then try 225 divided by 3. That's 75. There's no way to take 3 and 75 and make it a negative 30. Oops, my negative sign disappeared. Then try doing 225 divided by 4. It doesn't work. 225 divided by 5 is obviously going to work because it ends in 5. So that's 5 and 45. There's no way to take 5 and 45 and make it 30, although we're getting closer. Then try dividing by 6. It doesn't work evenly. Try dividing by 7. You're literally just going to keep trying until you find that right pair if you do not know the right pair off the top of your head. So I've been trying all. The next one I got was 9, so 9 and 25. Again, I'm getting closer to that negative 30, but I'm still not there. 10 is not going to work. 11 is not going to work. 12 doesn't work. 13 doesn't work. 14 doesn't work. And then we get 15, and 15 and 15 is our last pair of factors. And I can take 15 and 15 and make a negative 30 out of that if I make them both negative. And I need to make them both negative in order for them to multiply to give me a positive 225. So negative 15 times negative 15 is positive 225, and negative 15 plus negative 15 is negative 30. So now I'm going to take my fractions, I'm going to simplify them. They are both divisible by 3, so that becomes negative 5 over 3 for both of them. Take each of those factors, and we are ready to do bottoms up. So I'm going to throw my x's in the bottom. So I've got my original GCF of 3. I've got 3x minus 5 for my one on the left, and 3x minus 5 for the one on the right. So two of the factors are the same, and you'll learn in Algebra 2 that that's called multiplicity when you have a repeated factor. So another way to write this would be 3 times 3x minus 5, and then squared since it's multiplied by itself. All right, so when you have an equal sign, like this problem, it is an equation, and so we are going to need to actually solve and find the values of x. So in the first 6 problems, we learned how to factor, But factoring will lead you to finding the solutions, also known as the roots, the zeros, or when you start graphing, the x-intercepts. So you're going to follow all of the same exact steps, and then once you get it into factored form, there will be an additional step. So is it in standard form? Yes. Is there a GCF? No, not for this one. So we're ready to identify A, B, and C and get our star. So our A is 10. Our B is 19, and our C is 6. So we do the star. Up top is A times C, so that's 10 times 6, which is 60. In the bottom is B, which is 19, and we're going to divide each of those by 10. So our factors of 60, but we need them to add to give you 19. So factors of 60 would be 1 and 60. That doesn't give you 19. 2 and 30 doesn't give you 19. 3 and 20 doesn't give you 19. 4 and 15, that does give you 19. Sometimes there's more than one pair, so I'm just going to finish it off. 5 and 12, 6 and 10. And those would be all your factored pairs. So 4 and 15 is the only pair that you can arrange to give you 19. So those are going to be the two numbers that we use. They're going to both be positive because the 60 is positive. So positive 4 times positive 15 is positive 60. And then positive 4 plus 15 is 19. We're going to simplify these fractions. So the 4 over 10, they're both divisible by 2. So that becomes 2 over 5. And then for 15 over 10, those are both divisible by 5. So that becomes 3 over 2. Now we are ready to take those factors and do bottoms up. So when you're writing your factored form, remember GCF first. There is no GCF. So on the one on the left, this is going to become 5x plus 2. 5x is in the bottom, and when we go up, there's a positive 2. And then for the one on the right, in the bottom is 2x, up is a positive 3. So that is going to be our factored form. To get our solutions, we're going to take each of those factors. So I'm going to take that 5x plus 2, and I'm going to set that equal to 0. I'm also going to take the 2x plus 3 and set it equal to 0, because if the factors multiplied together equals 0, like it says in the problem, then one of those factors has to equal 0. That's the only way to multiply two things together to give you 0. So once you do that, this should be 1 or 2 step solving depending on the factor. So for 5x plus 2 equals 0, I'm going to subtract 2 from both sides, which gives me 5x equals negative 2. And then I'm going to divide both sides by 5, so x will equal negative 2/5. Please do not turn those to decimals, and you should never be able to simplify them. If you can simplify them, that means you did not simplify when you created your fractions up at the top in the star. For the next one, I'm going to subtract 3 from both sides. Gives me 2x equals negative 3. Divide both sides by 2. So x will equal negative 3/2. So negative 2/5 and negative 3/2 are the solutions. So again, still going to follow all the steps for factoring, and then get from factored form to solutions, you take each of those factors, set them equal to 0, and solve for x. All right, so let's try another one. We've got 9x squared minus 30x minus 24 equals 0. It's in standard form, GCF. They are all divisible by 3. So I'm going to start by dividing everything by 3. So when I do that, that's going to give me 3 on the outside. 9x squared divided by 3 is 3x squared. 30x divided by 3 is negative 10x. And then negative 24 divided by 3 is negative 8. My new value of A is 3, my new value of B is negative 10, and my C value is negative 8. All right, so we do our star. A times C is negative 24. B is negative 10, and we're going to end up dividing both of those by 3 because that's the new A value. All right, so this is one that sometimes students pick the wrong pair. So I'm just going to go ahead and list out all the pairs. So we've got 1 and 24, 2 and 12, 3 and 8, and then 4 and 6. So if you're looking at your combinations, there's actually 2 pairs that we can manipulate to give us negative 10. But only one pair will work with the correct signs. So let's say you think it's 4 and 6, right? And so you use 4 and 6, and then you say, okay, well, to get that to be negative 10, I have to make them both negative. Okay, so let's check it. Is negative 4 plus negative 6 negative 10? Yes. Is negative 4 times negative 6 negative 24? And no, it's not. So because you can get the sum correct but not the product, then that means that that is not the right pair. So it must be the 2 and the 12. So let's use 2 and 12. In order to make that a negative 10, the 12, the bigger number, would need to be negative. And if I multiply 2 times negative 12, it does give me negative 24. And if I add 2 and negative 12, it does give me negative 10. So be really careful because there are some numbers like this 24 and 10, also 30 and 13, that students often confuse or mistake those pairs. So let's see if we can simplify. 2 over 3 does not simplify, so that fraction is ready to go. But negative 12 over 3, those are both divisible by 3, so that becomes negative 4 over 1. So we're going to look at those fractions, and we are going to make them factors by doing bottoms up. So let's not forget our original GCF of 3. And then for my factor on the left, I've got 2 over 3x, so bottoms up, that becomes 3x plus 2. And for my fraction on the right, I've got negative 4 over 1, so if that's bottoms up, that becomes 1x, or just x minus 4. And again, this time it's equal to 0. It's not just an expression, it's an equation. So I have 3 factors. I've got 3, that's my greatest common factor. And then I have 3x plus 2, that's a binomial factor. And I also have x minus 4, which is another binomial factor. So if the 3 of them multiplied together gives me 0, that means one of those 3 factors must be 0. So either 3 equals 0, which makes no sense, that's impossible. 3x plus 2 equals 0, which is possible, or x minus 4 equals 0. So again, 3 can't equal 0. So although it's a greatest common factor, it does not give me a solution. So I'm going to solve my other 2 equations. So 3x plus 2 equals 0. I'm going to subtract 2 from both sides. That gives me 3x equals negative 2. And then I'm going to divide both sides by 3. That doesn't simplify. It never should simplify, so the solution would be negative 2/3. Again, do not change that to a decimal. If you have an improper fraction, leave it as an improper fraction. Don't change it to a mixed number. On the other one, we have x minus 4 equals 0, so I'm going to add 4 to both sides, and that just gives me x equals 4. There's no coefficient in front of x, so I don't have to worry about dividing by anything. So my other solution is x equals 4. So solutions are also known as roots, zeros, and x-intercepts. So you'll notice that the terminology is sometimes different depending on what you're looking at. So again, factored form is when you write it as factors. So we started in standard form. We took it and made it into factored form by factoring. And then once we had it in factored form, we found our solutions or our roots or our zeros or our x-intercepts. All right, standard form, check. GCF, at initial glance, you might say no, but I'm noticing that it has a negative a value, and I know from experience that it can make factoring a little bit tricky. So I would suggest dividing everything by -1 just to make life a little bit easier. So I'm basically forcing a GCF of -1. So when I do that, all that's going to do is not going to change any of the numbers. It's just going to change everything from a positive to a negative or a negative to a positive. So it's going to flip all the signs of every term. So our A is 6, the B value is -11, and our C value is 3. So A times C is going to be 18 because 6 times 3 is 18. B is -11, and I'm going to need to divide by 6. So what are our factor pairs for 18? Well, we have 1 and 18. That's not going to give me 11. 2 and 9. Well, that seems like I could get an 11 out of that. 3 and 6. And that's it. So the only one I can get an 11 out of is 2 and 9. And the only way to get a -11 is if they are both negative. And if they're both negative, that's a good thing because when I multiply them together, that would give me positive 18. So let's see if we can simplify these fractions. -2 over 6, those are both divisible by 2. So that becomes -1 over 3. And then -6 and -9 and 6 are both divisible by 3, so that gives me -3 over 2. So we're going to take these fractions and make them factors. Remember that we did take out a GCF of -1, so I'm going to put that in front. You don't really need to write the 1, but you definitely need to write a negative. So for the fraction on the left, -1 over 3, I'm going to throw my x on that. So bottoms up, 3x minus 1. -3 over 2, throw the x on the 2. Bottoms up, 2x minus 3. So for this one, I have 3 factors. I've got the -1 that I took out. I've got the 3x minus 1. And then I also have the 2x minus 3. So if I multiply those 3 factors together and that equals 0, that means one of those factors has to be 0 as a whole, because the only way to multiply and get 0 is if one of your numbers is 0, and that's called the zero product property. Well, -1 can't equal 0, so that doesn't make sense. So I'm going to take my 3x minus 1, set that equal to 0, and I'm going to set that 2x minus 3 equal to 0 as well, and we're going to solve these. So for 3x minus 1 equals 0, we're going to add 1 to both sides. That gives us 3x equals 1, divide by 3. So our first solution is x equals 1/3. For 2x minus 3, add 3, which gives me 2x equals 3, and then divide by 2. So my other solution is x equals 3 over 2. Because all of these equations are quadratics, they're called quadratics because their biggest exponent is a 2. The most number of solutions we should get is 2. When factoring, you usually get 2 solutions. However, you could get 1 solution. And then next year, you'll learn about when there are no solutions. If there are no solutions, it's not going to be factorable. Well, we're going to finish up, look at a couple more problems. All right, so for our next one, we have 10x squared plus 2x equals 0. So it's in standard form. This one does look a little different because there's only 2 terms, so this is one of our special cases. For this one, it's our constant that's missing, so our C is 0 for this problem. But it's all right, we're still going to treat it like every other problem. Again, it's already in standard form. Now we're looking for a GCF, and it does have a GCF. 2 goes into both 10 and 2, but they also have an x in common. Because it doesn't have a constant, they both have an x. So I'm going to divide both of these by 2x, which is going to leave me 10 divided by 2 is 5. And if you take an x squared and then take an x away from it, it becomes 5x. And then 2 divided by 2 is 1, and x divided by x will be no more x's, so 5x plus 1. So what you'll notice is when you take that GCF out, if you take the right GCF out, 2x, that's the key, is the x is taken out, you no longer have an x squared in your factor. So because there is no x squared in your factor, There is no A, and you cannot do the star. So that is as far as we can go. This is just like example 4, where because C is 0, this is a GCF only problem. So you are actually done factoring. And now you're ready to solve. So again, we have two factors. We have 2x plus 1 is one factor, and then the other factor is 5x plus 1. So if 2x times 5x plus 1 is 0, then either 2x has to equal 0, which is possible, or 5x plus 1 has to equal 0, which is also possible. So let's start with the one on the left. To solve and get x by itself, I just need to divide by 2. And 0 divided by 2 is 0. So one of my roots or solutions or x-intercepts or zeros is 0. For the other one, I'm going to subtract 1, which gives me 5x equals negative 1. And then I'm going to divide by 5. And negative 1 divided by 5 is negative 1/5. Make sure that you do not write what I was just about to write, which is 5. It's negative 1/5, not 5. Anytime that C value is 0, just to reiterate what I said when we did example 4, anytime C is 0, it is a GCF only problem. And when it comes to solving, one of your solutions will always end up being 0. All right, let's take a look at number 11, which also has two terms, but what's missing this time is not the constant, it's the B value. Doesn't matter, keep going as normal. So it's in standard form. Is there a GCF? Yes, there is a GCF. GCF is 2. So we're going to divide both terms by 2. Remember, the 2 does not disappear. 8x squared divided by 2 is 4x squared, and 98 divided by 2 is negative 49. So our A value, since we have an x squared, we do have an A value of 4. We're missing B, which means B is 0, and C would be negative 49. So let's do our star. Up top is going to be, what do we have? 4 times 49, and 4 times 49 is 196, and it's a negative 196. And then our B goes in the bottom, 0, and then our A value is 4. When your B value is 0, that means your numbers have to be opposite, because the only way to get 0 is if you had like 2 and negative 2, 3 and negative 3. So what that means is that 196, hopefully, is a perfect square, because that's the only type of numbers that's going to be a number multiplied by itself. So you can sit here and list all the factors of 196 if you're not sure. There's nothing wrong with doing that. It's always nice to notice patterns, and we will be talking specifically about this pattern in another lesson. So you could divide by 2, that's 2 and 98. That's definitely not going to give me 0. Then you could divide by 3, it doesn't work nicely. Then you could divide by 4, which is 4 and 49. Okay? It's not divisible by 5. It's not divisible by 6. It is divisible by 7, 7 and 28. That's not going to give us 0. Not divisible by 8. Not divisible by 9. Not divisible by 10. Not divisible by 11. Not divisible by 12. Not divisible by 13. But when you get to 14, you'll realize it's 14 and 14. If you were familiar with your perfect squares, you may have come up with 14 and 14 right at the beginning. But it's not just going to be 14 and 14. It's going to be 14, and one of them needs to be negative. That way, when I multiply them, I get that negative 196, and when I add them, I get 0. So now I'm going to take those fractions and simplify them. 2 goes into both 14 and 4, so that becomes 7 over 2. And then the other one will become negative 7 over 2. So I'm going to take those fractions, and those fractions become factors by doing bottoms up. So now we're ready to do bottoms up. I'm going to throw my x in the denominator. Don't forget, if you took out a GCF, it is part of factored form, so we took out a GCF of 2. So for the fraction on the left, 7 over 2x becomes 2x plus 7, and the fraction on the right becomes 2x minus 7. So we have 3 total factors for this one. We have 2, the GCF, we have 2x plus 7, and then we have 2x minus 7. To get our solutions, we take those factors because if they multiplied give you 0, then one of them must equal 0. So either 2 equals 0, which doesn't make sense, 2x plus 7 equals 0, which we can solve that, or 2x minus 7 equals 0, which we can also solve that one. So let's start with the 2x plus 7 equals 0. We're going to subtract 7 from both sides, which gives us 2x equals negative 7. Divide both sides by 2. Please leave it as a fraction. It should never simplify. Don't change it to a mixed number. Just leave it as negative 7 over 2 as that improper fraction. For the other equation, we are going to add 7 and then divide by 2. So for this one, we get positive 7 over 2. When you have the same number for the solution, but they're just opposites, another way to write that would be plus or minus 7 over 2. But you can also write them out separately. It doesn't matter. It's just a kind of a preference. All right, and our final quadratic equation that we are solving by factoring. Standard form, check. GCF. At first glance, you might think the GCF is 3, but 3 does not go into 16. So there actually is no GCF of this one. So we're going to go straight into factoring. So A is 9, B is negative 24, and C is 16. So let's do our star. So we need to do 9 times 16 for the top, which is 144, and then our bottom, negative 24. Okay, you may know some factors of 144, but you probably don't know them all, so let's just go in order and find them all until we find the right pair. Obviously, 1 and 144 is the most obvious. No way for that to give us negative 24. Divided by 2, 2 and 72. Not going to give us negative 24. Divide by 3, 3 and 48. Not going to give us 24. Keep going. Try dividing by 4. That's 4 and 36. It's definitely not going to be divisible by 5, so I'm just going to skip that. Divide it by 6, which would be 6 and 24. So I'm getting closer to 24. I'm just not there. Try dividing by 7. Doesn't work. Try dividing by 8, which is 8 and 18. So that's getting close. It's not quite 24. I could get 26 out of that. Divided by 9, and I know 9 goes into it because I got 144 by multiplying 9 times 16. That gives us 25, so we're getting super close. 10 does not go into it. 11 does not go into it, but if you know your times tables, hopefully you remember that 12 times 12 is 144, and I can use 12 and 12, make them both negative, which will then make a negative 24 when you add them, but it still gives us positive 144 when we multiply. So now we're going to divide by A, which is 9, and we are going to simplify these fractions. 3 goes into both of them, so that would be negative 4 over 3 for both. And now we're going to do bottoms up using those fractions. So throw an X in the bottom. There was no GCF, so I don't need to worry about writing that. Bottoms up would give me 3x minus 4 for the one on the left, and the one on the right is also 3x minus 4 since they're the same. You could also write that as 3x minus 4 squared because they have the same factor. So when we go to solve this, although there are two factors, because they are the same, that means your solution is going to be the same. So you don't need to set 3x minus 4 equal to 0 and then 3x minus 4 equal to 0. That would be redundant, and you'd be solving two of the exact same equations. So all you need to do is set one of those 3x minus 4s equal to 0. And to solve, you're going to add 4. And then you're going to divide by 3, so x will equal 4/3. So again, because you have a repeated factor, this is called multiplicity, and this is multiplicity of 2 because it's repeated twice. And so you have a solution. It's basically like a double root. Again, it's called multiplicity, and you will talk about that a lot in Algebra 2. So your solution, your root, your 0, your x-intercept is 4/3.